And now I would like to show you something in which the whole thing works the same way, another solution as in Revit. We will close the Revit now. And now we will go to the next solution, which is coming from Tekla. Tekla, you might know, you might have heard that Tekla is a structural design and a manufacturer company, which means that they are very good in detailing. It's a very expensive solution, but they are I would say they are the kings of detailing. They can do any kind of detailing and even send it out for CAM machines to make the cut of the steel structures and also the reinforced concrete. They are still an independent company, and they are represented in 14 countries. We're very similar the size to GRAPHISOFT. The software is speaking 13 languages, and they have 30 localized environments, structural environments. And remember this, they are very keen in detailing and very good. So, what is the workflow here? It works the same way as with Revit Structure, but here and now, here, for the first time in the history of New Zealand, you will see Tekla on the left screen. Tekla Structures. We have given this same building to the Tekla Structure guys. We told them, okay, if you are so good at detailing, make the details of the entrance. So, they are tough guys, and they did it. Look at this. As you see, as I've told, that even the last screw and bolt and all the steel plates can be seen on the details of these beams and steel profiles. There it is. And now you will see something. We have exported this model, and you will see something that you have never seen before in ArchiCAD. So I will ask Mark to switch to the Tekla part and look at that. So from now on, you can import, even if it's a very detailed model, anything from the structural application. Furthermore, I will show you one more part here. Just a minute. It's not that easy with Tekla either. Here is the foundation of this building, right? There are the nice details. And if I switch on transparency, you can see that all the rebars here. This is what Tekla does very efficiently. And now you will see something what you have never seen in ArchiCAD on the other side. You get the same rebars there. And it is imported in an intelligent way. It won't fill your library up with thousands of rebars. All those, if you select them, you see all those all the blue ones are just one object and stored ones in the file. They are embedded in the file, so you don't have to load each time a library. The file takes these parts with it whenever you want it. And as you see, the speed is astonishing because there are thousands of polygons, but still ArchiCAD can handle it very easily. So, let me summarize a little bit about the structural workflow. What we have seen here is the modeling, the model filtering and classification, the export, the referencing, and the coordination. We have created these translators for most of the structural applications, but you will ask, okay, what about the MEP engineers? So what about them? What about the model and intelligent model exchange with them? So here I will switch now to Revit MEP, and we will see what happened there. And here you have a part of this building with the ducts, HVAC ducts, and different tubes modeled in Revit MEP by the Revit engineer. But before that, I would like to show you, go back a bit, and show you a case study. Why did we do it? There is an office in the US, for example, which is just an example, a case study, Quattroci architects, who for their architectural design, they use, of course, ArchiCAD. For their structural design, their consultant, their engineer uses Tekla Structures. And for the MEP design, their consultant, in the initial design phases, I mean, in the schematic and the design development, they use Revit MEP. And when they get to the construction documentation phase, they use plain AutoCAD because Revit MEP is not enough powerful. So how to overcome that? This is the way that to be able to exchange data with ArchiCAD. So let's go back here to Revit MEP. And here, I would look at this in the 3D. Let's have a look at this in the 3D box. Then it is converted to 3D. It takes a little bit of time. And there you have these ducts, as you see in Revit MEP, which are the MEP ducts. Furthermore, we created an add-in for this as well, as you see here. This is then when you export from Revit MEP to ArchiCAD, these ducts stay as a live intelligent system. They don't fall into stupid objects, separate objects. To prove that, we have exported this, and now Mark will open this view on the plan. Here is the floor plan view, and now let's see an axonometry. And now, after the axonometry comes in, within a few seconds, Mark will do something that, of course, an architect never does. He will modify the ducts. Why? Just to prove that it's an intelligent system and they don't fall apart. So he will grab that one and very simply go to that mode, and when he drags, as you see, the whole system is modified. So it's an intelligent system. He will be able to, if he grabs the central point of that, as you see, do. And there are the new elements, what he created. Of course, this is never done by an architect because it's not his job. But the architect can always make a collision detection and find out that which are those ducts which collide with different architectural elements. This will take a little bit more time. Why? Because here, what happens now is that it will check all the ducts with all the different partition walls, and will write out, ArchiCAD will find which are colliding and which not. So, but it's less than a minute what is left, and here, within a few seconds, we will get a dialog that tells us that, okay, how many collisions do we have? You see, there it is, that it found 200 collisions just in this. So, and we can, let's see how can we find it. Just opening the eye in the markup and zooming there. There it is. And you see the pink part, which is colored with a different, the highlighted one. You see, it just goes through the window, which is above that entrance door. So in this case, we should tell the MEP engineer that this is very nice, but he should maybe elevate the whole system around 200 millimeters higher. And you can go and check each of them one by one, that where are the collisions. So, as you've seen here, ArchiCAD and engineering now truly integrate. And they integrate, not as before, but in a very user-friendly way, as we usually do it in ArchiCAD, with optimized translators for all these applications, and the changes which happened are always available. You can track them because you are always able to compare the previous files which were sent by the engineer and only compare the changes which can be accepted or not. So here, I say thank you.